A horse, we sweat to cool down. Every day we lose at least half a litre of water through our skins. The warmer we are, the more we'll lose. Can you see the clouds of moisture coming from the horse's nostrils? The moisture comes from the lungs. Just by breathing, we're losing another half a litre of water every day. And when we go to the toilet, we lose even more. A horse's toilet is its stable, so removing the dirty bedding is a daily chore. The body gains water mainly by drinking, but quite a lot comes from our food. Even what looks like dry food contains a surprising amount of water. Just how much we can see by a simple experiment. Here's some human food. Pretty dry it looks too. Using an identical amount of this food, we removed all the water from it. It still looks much the same, but the dry food is now reduced in weight. So, to balance the two dishes, we must put back the amount of water we removed from the food. That's how much water there was in that food. Now, if our bodies gained too much fluid, our tissues would swell up, or our tissues would shrink. So we must keep a constant balance of water in our bodies. It's the kidneys that remove from the blood just enough fluid to keep this balance. The kidneys are well supplied with blood. Every day, more than 1,700 litres of blood are pumped through the kidneys. That's more than a litre a minute. Let's see what happens to it. Inside the kidney, the artery branches into a tree-like network. If we follow the fine blood vessels to the outer part of the kidney, we see they lead to tiny knots of microscopic arteries. There are about 1 million of these knots in each kidney. While the blood passes through these microscopic vessels, some of the liquid is filtered out. In this animation, we can see the blood flowing through, but some of the liquid is being forced out from the blood into a cup-shaped capsule surrounding the blood vessels. There are minute holes or pores in the thin walls. Though they're small enough to prevent blood cells and proteins getting out, water and simple substances like salt, glucose and urea do get through. So the kidney filters out not only the waste products from the blood, but also valuable substances too. What the kidney does next is to return these necessary substances back to the blood. Let's see where this happens. If we examine a piece of kidney tissue, it's possible to see very fine tubules that make up much of the tissue. In fact, there are 1 million tubules like this one in each kidney. At the top is the capsule, which, as we've seen, collects the fluid filtered from the blood. Into this capsule, we can inject a coloured dye and trace the path taken by the fluid as it passes through the kidney. This section of tube is twisted and tangled and interwoven with small blood vessels. Here, many of the useful substances that were filtered out of the blood are reabsorbed. Altogether, the kidneys remove about 170 litres of fluid from the blood every day. And as it travels through the tubules, about 99% of this fluid is returned to the blood. As it flows back towards the outer surface of the kidney, water and salt are still being extracted and returned to the blood. There's a sensitive mechanism that makes sure the body retains what it needs and gets rid of what it doesn't. Now, this waste fluid, the urine, flows into larger tubes called collecting ducts. Finally, these ducts join up and drain the urine out of the kidney. When it leaves the kidney, the urine contains only those substances which are of no further use to the body. If the kidneys stopped working, fluid and poisonous waste products could not be filtered out of the bloodstream. A year ago, this happened to Colin. Fortunately, he's very much alive because he has a machine to filter his blood. For 3 nights every week, he's linked to this artificial kidney machine at his home. His blood flows through a tube to a machine that pumps the blood to the filter. This draws off the waste products, and then the filtered blood returns to the body. It takes about 10 hours to rid the body of unwanted substances, and the process, called dialysis, must be repeated every 2 or 3 days.
Well, if they're going to book it, I mean, you have to.
Apart from the dialysis, Colin leads a fairly normal life. He rarely misses school or games, and then it's always home to a good supper.
Well, I have to have at least 2 cooked meals a day, but I find it very hard to eat most of the time, but I need to eat it to keep my strength up.
My geography teacher will. I'll ask him on Monday.
I'm not allowed much excess salt on potatoes and things like that because the kidneys are the organs that take the salt out through the urine, and the problem is if you have too much salt then it builds up inside the bloodstream and you can't get rid of it all. Well, I can only have a pint of fluid a day because the real reason that we've got a machine is to take fluid off, and so I can't have too much fluid or else I'd have to have more fluid taken off while I was on dialysis.
I think that's your ration.
Thank you.
That's your lot for the day.
Yeah.
Never mind, you can have some more now when you're on the machine.
Good.
Once a week, the artificial kidney has to be rebuilt. Colin's parents learnt how to do this at a special course run by the hospital. The blood flows between 2 of these clear membranes. They're semi-permeable membranes. That is, they allow only certain substances, the waste products, to pass through them. It's between this board and the outer surface of the membrane that another fluid flows, carrying away the waste products that slowly filter through from the blood. Finally, the artificial kidney must be thoroughly tested. Then it will last for 3 dialysis sessions before the membranes must be replaced.
Small chopped spuds, cheese pie.
After supper, every Monday, Wednesday and Friday, Colin must set up for dialysis.
I better go and set up the machine now.
Fine, get to work then.
Setting up takes about 3/4 of an hour. Every step must be carried out with absolute accuracy. Nothing can be skimped or forgotten. Colin was started on dialysis at hospital when his kidneys became too diseased to function. After 4 months, a kidney machine was installed at his home, and by that time, Colin had learned how to set up the life-saving apparatus. The machine has a number of safety alarms which will sound if something goes wrong during dialysis. All these must be tested.
One of the alarms I use is to tell me the pressure of blood inside the kidney. Another one is to tell me the amount of fluid being removed from the blood. And the third one is to tell me the temperature inside the filter. Between each dialysis I put on about 2 kilos. This is excess fluid, so I need to take it off during dialysis.
Right, Colin, what's your weight?
43.4 kilos.
43.4. Found it tonight?
Oh, yeah. Before I go on dialysis, my blood pressure is higher than usual because of the excess chemicals in my bloodstream that I can't get rid of, and the machine takes them off, so when I come off the machine, my blood pressure is usually down to a normal level again.
130/90.
130/90.
Yes,
Really
quite good.
high. Yeah. When I come to put my needles in, I have to clean my arm first of all, and then into the area where I'm going to put the needle I put a local anaesthetic. Then I put the large needle through the skin into the vein.
It's not in yet. No, but it's giving. Go deeper.
On dialysis I use 2 needles. One is pointing in the opposite direction of the flow in my vein to get the full pressure pushing it out into the system. The other needle coming back in again is pointing in the same direction as the flow, so it pulls all the blood back into the vein.
Tape. That was really good.
When the needles are in, I can usually relax because I know that I've got them in and I've got over the worst part of the dialysis, so I feel pretty good then. Yeah, it's coming through. That's fine. The air coming out.
It takes less than 2 minutes for the blood to circulate through the machine and back into the arm. For the next 10 hours, Colin has a working kidney again.
The one consolation of being on dialysis is that I can eat and drink as though my kidney was working again. I look forward to having things I can't usually have, things with excess salt like crisps and peanuts and things like that. And I also am allowed to drink as much as I like for the first 5 hours. I have confidence in the machine, so I can sleep all the way through the night without worrying, because I know if anything goes wrong an alarm will go off and wake me up. I think I'm very lucky to have the machine, and I accept the inconvenience because there's no real alternative. I hope in the future to have a transplant, then I'll be rid of the machine and I'll be able to live a reasonably normal life.
Because of a shortage of machines and trained personnel, not all the people who need a machine to live actually get one. So many die. Ideally, a machine should be used to get the patient well enough for a transplant operation. But in Britain, hundreds of patients have to wait several years on a machine because not enough donor kidneys are made available.
We have left the scene of the accident. We're on the way to you. There's a young girl who has head injuries and leg injuries, and she will require portable X-ray on arrival.
A patient who is very severely injured is rushed to the intensive care unit of the hospital. The staff do everything possible to keep the patient alive, but sometimes even the most advanced medical care can't save life. In their efforts to keep him alive, the staff may not realize that the patient is a potential kidney donor. If he dies, he must be removed within an hour of death if they are to be usable for transplantation. So, at this difficult time, the grief-stricken relatives may have to be contacted for permission to remove the kidneys. The death of one person can bring extended life to another. The transplant operation is relatively straightforward. The patient's failed kidneys may be left in place, and a single donor kidney is put down in the groin and connected to blood vessels nearby. The first stage is to prepare the artery and vein for connecting to the donor kidney. That's the artery pulsating away, with the vein underneath it. The vein will be attached first. The stump of the vein on the kidney will be sewn into an incision made in the vein in the body. Now the artery on the kidney is joined to a branch of the artery in the groin. Once the arteries and veins are joined, the blood can flow through the kidney. Then the stump of the ureter is connected to the bladder and sewn into place. Nearly 500 transplant operations are performed every year in Britain, but even so, hundreds of patients are still waiting to be offered a suitable donor kidney. Andrew was one of the lucky ones. He had a transplant 3 years ago, and 6 months later started work at these stores, where he's now a sales representative.
At the point of transplant, I was very weak and wasn't able to walk about much or lift or anything like this. After transplant, I became on a normal diet, and I gradually got stronger and stronger and able to do more and more until now I'm able to do just about normally, except of course lifting, this sort of thing, and any strenuous exercise which might injure the kidney. I owe my life to the doctors and surgeons who made this transplant possible, and all who helped when I was on dialysis and kept me alive during the first years of illness. Since the transplant, I've never looked back. I've got better and better all the time, until I shall lead a completely normal life fairly shortly.